Okay, well, I think maybe let's get the talk started. This morning, Carly Goodwin will be talking about the HeliScan microCT system, and in particular, how to get your samples into the system so that you can get some good results. So coming up, there will be a talk by Dr. Yoshi Narui on cryo matters. So stay tuned to the website for details on that. So with that, I think I will turn it over to Carly and let her continue.
Thank you for the introduction, Hank. Good morning, everyone, and thank you for joining me today for today's Beyond the Scope webinar. Today's topic is Introduction to the HeliScan microCT and how to mount your sample. I'm Carly Goodwin, and I'm a research associate here at the Center for Electron Microscopy and Analysis, and I manage our HeliScan microCT system. If you have attended any of our previous Beyond the Scope webinars, you know we usually start with a couple of introductory slides about information about the instrumentation and resources available at CMAS, and also some info about their presenter's background. This will be followed by an overview of the HeliScan microCT, and then some advice and examples of how to prepare your sample. I just want to point out there are many ways to mount samples, and every sample is different, so we're only going to go through a few. I'll aim to keep this talk short, so there'll be lots of time at the end for questions. Please place any questions in the Q&A, and if you have any longer questions, there's also a raise your hand option, which can be used at the end of the webinar. Or if you have a question that you would prefer to discuss offline, please drop me an email and we can set up a Zoom call. And also, if you're having any technical issues, please post a comment in our chat and our moderators will try to help you. CMAS is a custom-built electron microscopy center, and we have a large range of electron microscopy and other microscopes and other analytical techniques. This includes our Titan and Themis TEMs, and on the cryo-TEM side, we have Glacios and Krios. We also have 2 focus ion beams, 4 SEMs, as well as XRD and nano indentation capabilities. And of course, the instrument we're discussing today, the HeliScan microCT. CMAS offers a range of different resources, including our Beyond the Scope, which you're attending today. We also offer one-on-one consultations. So if you're interested in learning any more about any of the instruments available at CMAS or discussing a project, please reach out to us. We also offer limited remote connection to our data analysis computers to analyze data collected at CMAS. A bit about me. I grew up in South Australia and completed my Bachelor of Engineering at the University of Adelaide. After university, I worked as a lab engineer performing the microCT experimental part of a digital rock analysis workflow. Then I spent a year working as a technical officer at the Tyree X-ray lab at the University of New South Wales before joining the CMAS team in 2018. In my free time, I enjoy going for walks at the metro parks around Columbus. Now let's talk about the HeliScan microCT. The HeliScan can perform both helical and circular scanning trajectories. It has a Z vertical stage, which can move 195 millimeters vertically. This combined with the helical scanning trajectories mean that samples with large aspect ratios can be imaged in one scan. The sample stage can hold a maximum of 15 kilos, allowing for heavy samples or sample cells to be mounted. The HeliScan has 2 scanning modes. The standard mode using a tungsten filament. The smallest achievable voxel size in this mode is 800 nanometers, and the maximum tube voltage is 160 kV. This mode is good if you want to image larger, more dense samples. The other mode is the high resolution, low flux mode using a Lab 6 filament. The smallest achievable voxel size in this mode is 400 nanometers. And in this mode, the maximum tube voltage is 100 kilovolts. This mode is good if you want to image smaller samples and want to achieve a very small voxel size. Achieving these small voxel sizes is dependent on your sample geometry, and you need to have a very small sample, say around 1 to 2 millimeters in diameter or smaller. If you have a slightly larger sample, you can use region of interest scanning. The HeliScan has a region of the region of interest workflow, which I discussed in my previous webinar. It also has a multi-scan workflow. This multi-scan workflow allows you to take either images of the same sample with different scan settings, or to stack several samples on top of each other and set up individual scans for each. This is a really good option if you have a few samples to run and want to run it over a weekend. There's also phase contrast retrieval, which can be very useful when looking at samples which have low X-ray attenuation. The HeliScan at CMAS has been used to image a variety of different samples. On this slide, you can see a few, including a slice from a honeybee head and also a compressed biscuit. And in image C, you can see a 3D volume rendering of a tomogram of a mouse heart, where the 3 different parts of the heart, the pulmonary valve, the resin, where the 3 different parts, the mouse heart, the pulmonary valve, and the resin it's embedded in are shown in different colors. So how does a microCT work? You have your sample, which is placed between an X-ray source and a detector. As the X-rays produced by the X-ray source pass through the sample, they are attenuated, and different materials will attenuate the X-rays differently. And then an image is captured on the detector. The sample will be rotated through a set trajectory, and many different projections of the sample will be acquired. After all the projections have been acquired, they will be reconstructed into a 3D data set using the HeliScan's recon code. Once you have your reconstructed 3D data set, you can use an image analysis software like Aviso or MyPar to segment, analyze, and visualize your data. During the rest of the talk, we will discuss the first step of the workflow shown in this diagram, the sample preparation. Now let's have a look at our first example. This is the Sweetgum seed that I used as an example in my previous webinar. It's about 40 millimeters in diameter. Since it's an irregular shape, I've used Play-Doh to create a more flat bottom surface and then used double-sided tape to attach it to a sample post. The mounted sample is then loaded into the sample stage of the X-ray source, into the sample stage of the HeliScan. And you can see that I've positioned the sample so that the height-wise, it's about in the midpoint on the vertical height of the X-ray source. So it's about where the X-rays will come out. There are a lot of different and creative ways that samples can be mounted for microCT imaging, but one of the main rules is that you don't want your sample to move. So make sure that however you fix it to the post, or if you put it in a container, that the sample is going to remain stable during the whole scan. Also, if you're using a sample if you have a sample that is wet or is likely to change during the scan, you really want to prevent that from happening. So you don't want a sample drying out or changing during the scan. And also if there's fluids in your sample or in your sample setup, you want to make sure those fluids don't move. For this Sweetgum seed sample, I just stuck it onto a 1.5 inch diameter post that's available at CMAS to use. But what other type of posts or rods could you use? At CMAS, we also have a 1 inch metal post that you can attach your samples to. But depending on the sample size, you could also glue the sample to the end of a glass pipette or a capillary tube, or you could use double-sided tape or glue to attach it to a piece of wooden dowel. The nice thing about wooden dowel is that it's readily available with different diameters from the hardware shops. One of the aims is when you're mounting your sample is to make sure whatever you're mounting your sample on has the same diameter or slightly smaller than your sample. If you mount the sample on a post that has a larger diameter, you're basically increasing the effective size of your sample, and this will limit the voxel size which you can achieve in your full field scan. Usually if I have a sample size of 8 millimeters diameter or smaller, I would use super glue and not double-sided tape to attach it. And finally, I just want to mention that when you're picking your post, ideally you'll have one that's at least 12 millimeters in length. This will just give you enough clearance to make sure when you're moving your sample up and down, you don't hit the source. As well as sticking samples to a post, you can also mount them in a holder or a container. Here you can see a photo of 2 phone batteries that have been placed in a sample holder, And then the holder has been padded out with a piece of styrofoam, some pieces of styrofoam to make sure the sample doesn't move. You can also use containers found around your lab, like the one shown in the photo. To load the samples and this container into the CT, you'll most likely then, to load the sample then into the CT, once you have them in these containers, you'll have to stick them to some sort of post. This photo shows a picture of a cicada, which we've imaged on the CT, and you can see that we've placed it in a small container and then used some cotton wool to make sure it doesn't move. When you're selecting your container, you want to make sure that the container you're mounting your sample has a very similar size. So in this diagram, the blue cylinder, the solid one is our sample, and then ideally you'd have a container highlighted by the just the blue outline. That's a very similar diameter. What you don't want is to have a sample container with a diameter much bigger than your sample, because this is going to limit the voxel size you can get of your scan. For our next example, we're going to look at a pair of honeybees mandrills. These samples and data are from Dr. Hung-Mei Lee Bali and her team at the Central State University. In the image on the left, you can see a 2D slice from a tomogram of a pair of bee mandrills. And on the right, you can see a volume rendering that was made in a VISO. These mandrills were dissected from the honeybee head and then glued onto a 2mm diameter wooden post. And you can see the post, just the top of it, at the bottom of the slice. So sometimes when we're preparing our sample for CT imaging, sometimes it can be useful to make your sample smaller than it originally is. So in this case, the mandrills were dissected from the bee heads, but because the rest of the head wasn't necessary for the scan and for the experiment they were running at that time. In these images, you can see a horizontal and vertical slice taken from a tomogram of a sandstone, which was mounted in a glass NMR tube. This data is from Dr. Sheets at the School of Earth Sciences at OSU. When we went to mount this sample, we filled the NMR tube about 3/4 of the way with sand. And the plan was to sit the sample on top of that sand. However, the rocks plug was slightly larger at the top, and when we placed the sample in, it became stuck. And you can even see that this NMR tube is slightly cracked. On the positive side, the sample was now firmly stuck in the NMR tube, which meant it was possible to scan the image, scan the sample with no sample movement. NMR tubes are really nice sample holders because they're very straight, and they also can be purchased in a range of sizes. They're also good for mounting powders in, because you can just pour your powder and fill it all up, or you can seal the top of the NMR tube and place a sample on top. So on this slide, I'd just like to point out a few things about scanning wet samples on the HeliScan. The first one is that it's possible to scan samples that are either fully saturated or partially saturated. The samples aren't under vacuum when they're scanned, but your sample does need to be stable, as previously mentioned. So you don't want it floating around in liquid or drying out during the scan. And also I ask that if you do bring a sample in that's wet or mounted in fluid, please make sure it's properly sealed so that it doesn't leak during the scan. Fluid leaking is bad for your scan because it'll cause artifacts, but it's also very bad for the machine. And finally, I'm going to talk quickly about imaging of biological samples. If you're working with biological samples like tissues or plant materials, you might want to think about the following 3 options. The samples could be chemically fixed to preserve them. From a safety perspective, any animal tissue which is going to be imaged on the HeliScan as CMAS should be chemically fixed. If you need more information about this, or if for some reason you can't fix your sample and you still want to discuss what options you have, please reach out to our lab manager, Sarah McCullough, for further information. Since soft biological samples are usually not very X-ray attenuating, it may be worthwhile thinking about staining your samples with heavy metals. This will help improve the contrast between your features. And finally, you could think about resin embedding your sample. This will help your sample. This will help you limit your sample from moving during the scan, and it will also be useful if you plan to perform other imaging using other imaging techniques at CMAS. In this photo, you can see a piece of heart muscle from Sci Biomedical Engineering. The sample has been fixed, stained, and embedded by Sarah McCullough here at CMAS. And then we mounted, and then we stuck the one on the left on a post and performed a region of interest scan on it. It was possible to get a tomogram with a voxel size of about 880 nanometers from the sample on the left. However, we wanted to see what we could see if we had a smaller voxel size. So we cut off a small bit of the two small pieces from the top of the sample, and then we chose one of those pieces and glued it to the end of the pipette. And then I rescanned it on the HeliScan with a voxel size of 420 nanometers. So our next webinar will be on the 28th of May, and will be on a cryo-related topic, and you can register for the webinar at the CMAS events page. Don't forget to stay connected with us via our website, LinkedIn, or Facebook. All our previous Beyond the Scope webinars can be found on our YouTube page. Thank you for joining me today. I hope everyone has a good rest of the day. If you have any questions, please use the raise your hand option or add them into the Q&A box.
Thank you, Carly. Are there any questions for her? Well, if there are no questions, here's a question. What are your tips for imaging samples in solution? What are acceptable liquid holders?
I would go for anything where the sample will not, where the liquid will not leak. On the HeliScan, you need the sample to be mounted quite high. So if you're going to use something like an NMR tube, you might want to fill the tube up so that your sample sits in the top few quarters. Acceptable containers from, I guess, an instrument manager point of view, anything where there's a lid that can be sealed is really good. And anything where you can make sure your samples don't leak. From a scanning point of view, you want something where you can also hold your sample firmly, and you want, if you have the container, you don't want to add a lot of extra size to your sample. So if you had like a 5mm sample, but you put it in a 20mm diameter container, you're basically making your sample equivalent to being a 20mm diameter sample. So you want to keep the container as small as possible, but where your sample will still be held correctly without moving, and where it won't leak. When it comes to actually imaging things in solutions, I'd also suggest making sure, unless you're doing sort of wet-dry imaging and doing doing subtraction to find out different information about your sample, make sure that your solution doesn't have the same sort of attenuating X-ray attenuation as your sample. For instance, if you're imaging things like hydrogels, you probably don't want to put them in, have them surrounded by water, because, or you might not be able to tell the difference between the two. You might just get a gray cylinder.
So I have a question, Carly.
Yes.
How important is it that the sample be exactly on the rotation axis? How important is the centering of the sample?
If you're aiming to get the best voxel size possible, it's really important. If you're a bit more flexible and you're not aiming for the best possible, then you've got a lot more flexibility. But you still want to get it pretty close. Like, you don't want to sit it purposely off center. The HeliScan does have a region of interest stage, so you can do region of interest scans offset from that central axis. And also, what's nice about the region of interest stage is that you can use it to center your sample. So if your post doesn't quite rotate perfectly, you can tweak it a bit and sort of fix a small amount that way.
Okay.
Have you seen any problems using super glue with small samples in terms of stability of the glue in the beam? Good, that's a very good question. If you have freshly just put the glue on, so if you walk into the HeliScan room, mount your sample, leave it for 5 minutes and then put it on the machine, I think there could be some instability. I'd suggest leaving it for a few hours or even mounting it the day before, just to make sure the super glue is properly set.
If you're looking, Carly, at a liquid sample, can you actually look at something that's liquid and just increase the viscosity to keep particles within the liquid from moving?
Potentially, as long as those particles didn't actually move during the scan.
Okay.
And I guess if you're looking at the if you want to see the particles separate from the fluid, as long as they had different contrast.
Okay, thank you.
In line with the last question, could you freeze, for example, water? The problem is with freezing a sample, how would you make sure it stayed frozen and didn't defrost during the scan? So I guess you could freeze it, and then if you did a really quick scan, maybe, but really it's that sort of thawing that could cause you issues.
I think you could probably rig up some sort of a cooling mechanism for
I
it,
think so too.
but it would be an ad hoc solution. Well, if there are no other questions, I'd like to thank everyone for attending. And please join us for our next talk on May 28th. Thank you very much. Bye.